Hi all, so today we will see example 1 from the chapter 2, frequency response. So for this question we need to draw the body plots for the given transfer function, and regardless whether the transfer function given to you or you have to derive from the circuit. So once you have the transfer function, you need to modify this transfer function to suit the standard form. Okay, so in the standard form you can see that you shouldn't have like a number apart from 1 here, also here. So these two we have to make it as a 1. Okay, so I make a simple, you can use any mathematical modification. For me, I just factorize out the 2 out of this term. So here I will have j omega over 2 plus 1. So if you multiply this, you will get the j omega plus 2 again. Okay, and then 10 j omega over 10 plus 1. So these two actually you will have like a 20. Okay, so here I can simplify this term where I have at least plus 10 j omega over j omega plus 1, j omega over 10 plus, sorry, this is j omega over 2 plus 1. Okay, so the next step is actually we need to change this equation to decibels, in decibels, so you can draw the plot. So in dB, okay, so this is actually the k value. So here you will have like a 20 log 10, and this is on the top, so you'll have a positive 20 log j omega, and then this is actually the bottom part, so minus 20 log. So you just change this one according to the, what is that, the general term. We just shift the 1 here, swap it to look it like this, and here as well 20 log 1 plus j omega over 10. Okay, so this is in dB, and we can draw it later. I'll teach you on how to draw it. Then we need to also get the phase from this equation. Okay, for this term this is actually 0, and for this term this is actually 90. If you forgot, you actually can look at the table. J omega 90 degrees, okay, plus 90, and for this is, you will have like an inverse tangent of negative omega over 2. So where is it? Oh, that's actually how to plot later. This is actually just we get the from the general equation. Okay, so here we will have inverse minus inverse tangent of two. Okay, and the last one is inverse tangent of omega over 10. Okay, and this is y axis. So here we start from 0 point 1. Okay, 0.1. This is 1. This is 10. This is 100. This is 1000. Okay, and for the y-axis, the magnitude, I use 20, 40, negative 20. Okay, negative 40. Then I'm just preparing the semilograph first for me to plot. Okay, so we will draw one by one, then we will combine them, add all of them. So this first, let's say we label it first, second, third, and fourth. First is actually k, so this is actually 20 log the number. So here, since we have like a 10 log 10 will result 1, so 20 times 1 is still 20. So here you'll have like a first line is actually 20. Let's say we use this color. Line. Just draw a straight line at 20. Okay. This is number 1. Number 2, it will start from 1. Okay, start from 1. It will cross like this 1. Okay, with 20 dB per decade, the gradient or the slope. Let's say we use blue color here. Just draw a bigger line so that okay. And this is number 2. Number 3 is minus. Okay, so this will have like a minus 20 dB per decade, but initially it won't start. It will cross at 2. The frequency is 2, somewhere here. So 2 is actually here. Okay, we also label the 10 because later we will use 10. 10 is here. Okay, so for for this graph it will start from 0, then the 20 dB per decade, the slope it will start from the point of 2. Okay, if you look at the table here, I'm sorry, here you see before that 0 only at the start, at the frequency of 2 you will get like a 20 dB per decade. So we will have use red color line. So 20 dB per decade means per decade, this is 1 decade. 2 starts here and then end here, and 20 dB is actually here. So just mark for us to don't make any mistake. Okay, just pass through the 12 and 2 again. Okay, this third line, and fourth line, let's say we use blue color. Okay, this is also 20 dB per decade. I didn't choose yet. Why? Okay. blue color already used. Let's say use green. Okay, this is 20 dB ticket of the fourth line. So we have like 1 2 3 4. So this is 1, this is 2, 3, 4. So now we're going to combine all of them. If we draw separately and then we're going to combine. So we have to observe one by one. We have to select few points, then we actually can combine. And we always observe the turning point, you know, when there is changes with different type of lines. So for the first case, let's say we observe this 2 point here at 0.1. I want to plot. Okay, so here I have like a 20 and negative 20. So at this 0.1 I have like a 20 at 0.1. You know, we check one by one. I have negative 20 plus 20, so the resultant will be 0. So I'm going to mark here. Then at this point you see yeah, at this point we have changes because we have 3 lines, red, blue and orange. This is, we can consider like a turning point. And here we have a 20 at this is actually 2. Okay, at 2 we have 20 plus 0, red actually 0, blue we don't know yet, so we try to calculate that first. Okay, so here if you see this is actually 20 dB. We need to get the minor scale, how much actually minor tick. So this here we have 1 2 3 4 5. Okay, 5 box. So each will have like a 1 2 3 4 5. So we have like a 4. Okay. 4 6 sorry 4 8 12 16 20. Okay, so each minor tick we have like a 20, so 20 for us to get that 20. Okay, then we need to get the point here. This is almost like in between we have like a 6, so we can consider this as a 6 or 5, you know. Okay, sometimes that line actually slightly shifted, so this is actually we can consider like a 6. So here we have a 6, so I can say that 26 actually the total value here, which is around 26, almost same point where we have here. Okay, so the next turning point actually here, next turning point here, you can see that we have blue, orange, green and red. So we have like a few colors. Okay, so then we can get at 10 I have 20, the blue is actually 20, orange is also 20. Then what is that? The green is actually 0, and then the red is we need to get. Here we have -4, 8, 12, 16, all negative, So at this point it is almost around 14. Okay, here should be 14, -14, -14. I'll get like a 20, 20, 40, 40 minus 14 is actually 26 as well. So I can mark 26 here, same point like just now. Then finally, where is it? Is there any changes here after this? So let's say we take it 100. After the same, blue, orange, green, because green have some value before this is 0, right? Blue, orange, so at 100, blue is 20, blue is 40, orange is 20, orange 20, green is -20, and then red is so I need to get like a 24, 28, 32, 36, and this is in between 32 and 36, where I can say that this is 34, right? So -34. So I can say that I have like a, this can be cancelled. Okay, 40 minus 34 is actually 6. So at 100 I have a 6. For 6 actually here in between. And after that actually same, the pattern will be same because all of them will be same value, so it will be same. So I can draw the combined graph now. Combined graph now, where this will be from here to here, first line. Okay, then second line, third line. Let's draw a straight line like this. Okay, so this is actually the final result, the black color line. So first you have to draw separately each of them, then you have to combine that. This is actually done for the first graph, which is for the magnitude. Now we do the phase, the combination of the phase. You can draw a straight line as the x-axis first. Just draw a straight line here, somewhere here. Okay, then this will be the phase. Okay, this will be the phase of y-axis will be the phase. I can have like a 45 degrees each. The bigger box actually, major box actually 45 degrees. 45 degrees, 90. Okay, I need to go for 180, I think. Only when there is a what you call quadratic function here, we can go for 180. If there is no quadratic function, we can stop until 90. And at the negative side, I will have -45, -90, and here we will start with 0.1 like before, 1, 10, 100, 1000. Okay, and for phase it's actually quite different. Okay, you can refer to the table like what I have shown before in the slides, but I usually draw by like little understanding that phase actually will change at each point. So here, as for the phase, we also need to get like, if this is actually 2 means here will be the phase actually will start from 2 over 10. Okay, the point actually will be 2 over 10. You see for the phase, here's z, right? Z over 10. If it is p means p over 10. So in this case both of them actually will be pole, so p over 2 over 10 and 10 over 10 for the pole. Okay, so 0 nothing, first is actually start from 90 degree. Okay, first is 90 degree, so this is also we will draw separately each by each. So first let's say I use the orange color to draw the line. Okay, 90, and then second is, this will be on the negative decade, start at 0.2. So here I just want to clarify, the p is 2 over 10 which is 0.2, here the p is 10 over 10 which is 1. Okay, just first to do not make any mistake. So at 0.2 here, just mark here at 0.2, and this is actually 1, right? Okay, so at 0.2 I have like a 45 degree per decade. If you see, this is 45 degree per decade. Okay, at 0. I mean at 1 also same 45 degree per decade, and it will stop at plus minus 90, you know. Okay, so here it will start from first 2.0 here, and then per decade is here. Just want to mark first, and I'm going to draw the line. Oh, let's use blue for this case. It will stop at 90. Okay, and then it will go straight like this, you know, for okay, because if you see if you understand the basic of in the tangent graph, it will look like this. It goes like this, some curve, correct or not? The second part is to draw the, let's say we use green, to start from here, second pole. This is simple, and then after that also it will go with a negative 90. Okay, so I don't want to draw again on overlap again, but it goes with the same line, right? The next is next is actually to combine them. So you have to start from the first line. Okay, you cannot like start from the second line or third line. You have to start from the first, second, and third. You have to go one by one. So when I start from here, I use black color. 90. First turning point is actually 90, and then until the next turning point, which is 0.1, is not 0.1, 1. The changes is actually negative 45 degree per decade. The changes, we will follow the changes concept. This changes actually. So until it will go like this, correct or not? It's supposed to go like this, but it will stop it here. Okay, it will stop it here because we have another changing point here. It will stop it here. Supposedly it go until this point. Okay, 45 degree per decade, but it will stop here because we have another changing point, and at that changing point I have another 45 degree per decade. In total I will have like a minus 90 degree per decade. So from here to here I should have like a minus 90 degree per decade. The line should be more sharper. It will go until okay, to go until minus 90 degree means I need to check the point here. Okay, this is 45. Each of them actually 5. Yeah, here, exactly this point. Yes, this point, because after that we have a change. Okay, change, because after this you see we in total have like a 45 90 degree per decade. Okay, this actually will have like 90 degree per decade. After that this actually reduces where we only have like a 45 degree per decade here. Okay, 45 degree, 90 degree you cannot count it as a, it's actually like a maximum infinite position. Okay, so we have like a, you cannot simply just total, you know. So from here to here I will have this line. Because after this point I only have like a minus 40 degree per decade. Okay, this minus 90 you cannot inclusive in the minus 45 plus, or you cannot do like that. Okay, the changes essentially we only combine the gradient slope. Okay, we only will combine the slope, not the straight line like this. Straight line won't be combined. And then we have straight line like this. Okay, so this goes like this, and supposedly it will start again something like that somewhere here. Okay, so this is actually the total combination of the phase. So hope you understand. This is just for clarification again. Here the addition or subtraction only will happen when there is changes in the gradient. You know, not I cannot like this is actually the first point, right? You see from this point I'm only drawing the changes. Okay, 45 degree per decade, negative, in total negative 90 degree per decade. And then here I only have like a 45 degree per decade. After that join back the 90. This 90 and this 90 actually won't involve in the addition or subtraction. Okay, so this is actually quite different from the what is that, the magnitude we just add like that, correct or not? Okay, and this is HTB and this is omega. So I hope you understand, enjoy the session, and if you have any question you can contact me.